All right, hi everybody. So in this little video here, we're going to take a look at a problem where we're asked to rationalize. Now, this one might not strike you as a problem that requires rationalizing. You might look at this saying, well, it's not even a rational here. But you can always sort of think of this sort of an expression as a rational by simply putting it all over 1. And now, when I go to rationalize this, what I'm going to do is I'm going to multiply by the binomial conjugate. Because I've got two terms, I've got a binomial numerator, I am going to multiply by that binomial conjugate. And again, just so that you recognize this, if you were to simply square that binomial, you would see that it doesn't actually get rid of the radical. It moves it, okay, but it doesn't get rid of it because of the way the distribution works. When I use the binomial conjugate and do distribution here, I create a difference of squares. And so I have my first term, which is this kind of big thing, this square root of x squared plus 4x plus 5. That's going to get squared, in which case all that happens is I lose that square root. And then I'm going to get subtract x squared, okay, because that's the second term in the binomial multiplied together. So I get that whole thing squared, gets rid of the square root, and then I square the second term. In the denominator, I'm going to get 1 multiplied by the square root of x squared plus 4x plus 5 plus x. Now, in the numerator, it's nice because my x squared terms are going to cancel. And so I am simply left with 4x plus 5 over the square root of x squared plus 4x plus 5 plus x. And right there, that is about as good as it's going to get here. There was nothing in the denominator initially to cancel out with it, and so there we go. I've rationalized that expression.